Good evening, ma'am.
Hello, good evening. Hello, should we start now?
Yes, ma'am.
Yes, ma'am.
Share my screen. Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Okay, so this is the first problem. There are three problems in week 8. We are doing for week 8, right? Yeah,
Yes.
so we get problem solving session. So for this one, we are having three problems. The first problem is something, this is the first problem. So what happens in this problem here is we are given this two shorted list, each of having the same size, let's say n. Okay, both of them will have the same size n, and what we want to do is we want to merge these two lists. Okay, you have read the merge sort algorithm. In the merge sort algorithm, you will be able to merge these two lists, right? There is a function called
Yes.
merge function. Remember? Yes. So when you merge these two lists, like for example, for this sample input, what will be the merged list? Uh,
1, 2, 3, 4, 5, 6, 7, 8.
1, 2, 3. Uh,
Yeah.
sorry. Yeah, so the Mars list will be 1, 2, 3, 4, 5, 5, 7, and 8, right? So this is the Mars list. Now, what is the middle element of this Mars list? Okay, or what is the median in this Mars list? So what is the median? How do you calculate the median? If the list is odd numbered, like the list has odd number of elements, then it will be the middle element. Whatever is at n by 2 location, that will be the median. Okay. Otherwise, if it is in even list, then you take the two middle elements, the n by 2 floor and n by 2 seed. Okay. Take the two middle elements and then you find the average of them. That is the median. Okay. Is this clear? Is the
Yes, ma'am.
problem statement clear?
Yeah, ma'am.
Like for example, for this particular what will be the median? So here we are having these two lists, both of having the same size. We perform the merge operation, which gives us 1, 2, 3, 4, 5, 5, and then 7, 8. Okay. In this list, we have to find the median element. So which one is the median element here? The middle element. So there are two middle elements now, right? One is 4 and the other one is 5. Okay, so what we will do is we will take the average of these two elements, which is 4.5. Okay, that should be the output. But if there was 9 also, suppose there was 9 here also, okay, then which one will be the middle element or the median?
Fifth one.
This one, this 5, the 5 will be the middle element and hence it will be the median. Okay, so that is the problem statement. But now what I told you is like you just have to apply the merge operation and then you have to compute the length of the list divided by 2 and you get the median, right? So that is what is the running time complexity of this algorithm?
O of n.
O of n. But what the problem asks is you have to solve it in order of log n. Okay, that is the trick here. The question, the trick here is you have to solve this particular problem in order of log n. Now the question is how do you do this in order of log n? So see, here we are performing this merge operation from merge sort. What is the running time of merge sort operation? It was order of n log n, right? So
Yes.
somehow now the thing here is we want to do this in log n and notice that we just want to find one particular element in two sorted lists. We don't want to sort them. So somehow we just want to apply a divide and conquer approach similar to that of merge sort such that we will be able to solve in order of log n. Every time whenever you see this order of log n thing, then recall binary search or merge sort. Okay, somehow there should be some connection. Whichever it is the connection, you have to think to that angle. Should be some connection. Whichever it is the connection, you have to think to that angle. Like for this particular problem is connected to the merge sort problem. We are using the merge function from the merge sort, right? So that means that this is somehow connected to the merge sort. So think along the lines of merge sort, like how much, think for some 5 minutes or something, how the merge sort will look like, and then we will look into the, like, should we just try, should you try for a few minutes and then we will look, or should I just say the solution?
Yeah, ma'am, we can try for a few minutes.
Yeah, try for a few minutes and then we can discuss how to solve this. Okay. Actually, you know what? Think along binary search also. Think along how you solved binary search. What did you do for binary search?
Okay, ma'am.
Okay, for binary search, you used to find an element in one array, right? Given one array, you used to find one element. Now, what you are going to do, you are given two arrays and you want to find one element in these two arrays, right? So earlier you were was asked to find the position of one element in one array. Now what you have is there are two arrays and you are given the position of the element, you want to find the element, right? Get the difference
Yes.
between binary search and this one? Yeah. Should we discuss?
Yes, ma'am.
Okay. So any ideas on how to solve this? No. Okay, so how do we solve this? Any ideas on this? Okay, so what
Mm,
do we want? What we want is we are given this two arrays, right? We are having this, we have this A is equal to this list, then some list, it was one, two, what was the list? 1357, and B was equal to 1, 2, 2, 4, 5, 8. Okay, 2, 4, 5, 8. All right. So what we want is we want to find the middle element, right? So what we will do is we will take the low and the high as usual. We used to do. We used to see first of all n is equal to length of any one of these arrays, right? Any of these arrays you
Yes.
can just take the length and it will be fine with you. So we take the length of one of these arrays, and then what we will do is we want to assign this low and high as 0 and n. Okay. So low, what we will do is we will have a low for A and a high left for A, right for A, left for B, right for B, and then we will look at, compare them. Okay. So what is happening is what we will do first of all is okay. Do you want the first question is in binary search, you must have seen there is an iterative method and a recursive method, right? The recursive method involved recursion and the iterative method involves this loops and while loop solution. Which one do you prefer?
Iterative method.
Okay, so if we will go for iterative method, then what we used to do for binary search, how did we used to search for the element in binary search?
We find mid, which is low plus high divided by 2.
Yeah, so that is exactly what will be the condition for the while loop. Low should be less than equal to high, right?
Yeah.
And what we used to do is we will find the middle element, which will be low plus high by 2, right? Low plus high divided by 2, right? So now what we want is we are having these two arrays, right? So we need the middle element such that it will cover a middle set of elements in the merged list. What we want is see, we have this A list. This is the A list. This is the B list. The middle, we want when we will merge this two list, okay? When we will merge this two list, what we want is in this list, we want the middle element, right? So what we want is we want actually a set of elements such that the middle element should be covered, right? So when we take a middle element here, if we take the middle element of A and the middle element of B, what will happen? This set and this set will definitely cover a set of elements which will go in the middle of this. Do you agree to that? May
How
not
one
be.
I
May not be. May not be. Why may not? Because this set may come first, then this set may come first, right? So that is the trick here. We want to find this set of elements such that the middle set, such that it covers this middle elements. All the elements in the middle should be covered by this. Now let's say this is my middle element of the array A, and this is the middle element of the second array. Okay, so now tell me, how will you find which set of elements goes in this middle part? Is there a way to find which set of elements goes into this middle part? See, if
whose
sorry, yeah.
whose left part is less than the number and right part is greater than the number.
Yeah, there is another trick also that we will discuss next. So what the trick is, what we will do is we will assign two middle. One is for middle A and the second is for middle B. Okay. So middle B will be equal to n minus the middle element. Okay. So we take the nth element and we just find whatever is the middle for A. So initially what happens? Initially the middle for A is the middle element. Okay. And for if we take n minus the middle of A, then what will come for middle of B? It will again be the middle element. Right? Do you agree to this?
Yes.
Yeah. So now we took the middle elements. I'll run for one more iteration so you will understand what happens. But for this particular iteration, let's understand what is happening in the first iteration. Okay. So we take this two, let me just mark here. This is A, this is B, this is merged list. Okay. The merged list A and B. Okay. So what we will do is we took middle of B as the n minus middle of A. Now what we are going to do is we will assign a left boundary and a right boundary to both to A and B depending on this middle element, depending on where this middle element is present, okay, we will find some location to the left of it and to the right of it. Okay. Similarly, depending on where this middle element for the beat array is present, we will find the middle element, left element for B and the left element, right element for B. Okay. So how do we find that? So what we will do is, if my middle of A is equal to 0, okay, then it will be the left will be, what will be the left, what, this is the base case actually. If the middle element is 0, then what will happen? We don't have anything to the left, right? So my left of A will be equal to infinity, okay, or let's say this will be float of minus infinity. Okay, is this part clear?
Ma'am, middle of A is 0. That means on the left of uh, middle will be negative elements. That's why we are taking left as minus infinity.
Yes, that's why we were taking it as minus infinity. But for that part, let's just hold it for a little bit. When I will come to the next iteration, we will understand why we are considering that case. Okay. So for this particular case, let's just go with left of A as equal to uh, A of the middle element minus 1. This is fine, right? Just
Yeah.
the previous element and just the next element. This will be fine, right? For this middle element, whatever is the middle index, we will take the element previous to that and the element right to that. That is fine, right? This is my right of A will be equal to A of middle of A. This is clear?
Yes.
Similarly, we take left of B is equal to B of middle of B minus 1, and right of B is equal to B of middle of B. This is clear? So what we did is,
Ma'am,
until now, the summary, yes.
why we are taking the right element as the middle element itself?
We can do the opposite also. We can do, if this is the middle and this is plus 1 also. That's not
No,
a
I
problem.
mean, if right of A should be the element that is right of the middle, right?
Actually, you can do that also. Okay, but then what will happen is, if you do that, then that you will be considering with three elements here. Right now, I'm just considering two elements. When I am having
Okay.
this, when you are taking, this is the middle element. Okay. So when I am taking left of this, I'll just consider one element here and one element here. Okay. So we are having these two elements to consider. Okay, but if we are taking three elements, then it will just increase the complexity. Not the complexity, it will just like increase the complexness of understanding. Okay, just to
Okay.
reduce the number of elements that we are considering. See, in binary search, we were considering one element. Why did you consider one element? Why not two consecutive elements? Similar
Yeah.
question only. Okay.
Okay.
So what we will do is, we are just taking left of A is equal to middle of A minus 1 and right of A is the middle element. Okay, this part is clear, right? So the summary is, we are just finding the middle element for both of these two arrays, and we assigned the left element for the first array as the element previous to the middle element, and the right element as that particular middle element. So what we have now is, for both of this, if this is the middle element, we are just taking these two locations. One is this left of A, and one is this right of uh, B. Sorry, right of B. Right. So now in this scenario, tell me, where should this middle element lie? The median element. Where will it lie in this scenario?
left element of B. Left of B, I mean.
Left of B and right of A?
Yeah, I can also.
Why?
Because they are the only middle elements of when A and B will be merged, they will be coming in the middle.
When A and B will be merged, then they will be coming in the middle.
Yes.
Is that this one? Okay? Let's consider this. Sorry, you said left of B and right of A, right?
Yes, ma'am.
Okay, let's consider this um, particular scenario. This is the problem state. This is the two arrays. Array A is equal to. Why is this not visible? Okay,
What I
array
said
A.
will be true if elements of array A is less than elements of array B.
Yeah, but it is not necessary, right? If A is
Yeah.
equal to this and B is equal to 2, 13, 17, 30, and 45. Now what will happen in this scenario? Or let's say this is equal to 25. In this scenario, what will happen? Which one is the middle elements? This 12 and 15, right? Here we have, sorry, what is
Yes.
which one are the middle elements? First of all, determine which are the middle elements. So in
For
this
A, it's
case, we have
25.
0 plus 0, 1, 2, 3, 4 by 2. It's 2. Okay, yeah, for A it's 25 and what is for B? B
It's
will be
17.
17. Right. So now which one should be where should the middle element lie? See, your 2 will come somewhere over here, 13 comes somewhere over here, 17 comes previous to A, and then all of these goes after this, right?
Yes.
Yeah, that is the question. So it is not necessary that all of these elements will lie before, sorry, it is not, sorry, what I was trying to say is, I guess this is a bad example. Let's say this is 28, this is 130, 170, 28 comes here. No, what I'm trying to do is one of them will come here and the others will go there. Maybe this will be 25, this is 2, and this will be 27. Now notice what happens here. We have 25 as the middle element, 27 is the middle element. So for the elements which are previous to this is 25.5 assume, okay? There's no other elements between 25 and 26. So for what happens for B is one of the elements goes before the left of A and the remaining two elements goes to the right after right of A, right? How do we determine in this scenario? Okay, so what we do is we will compare left of A and right left of B and sorry right of B. We will compare the positions of left of A and right of B. Okay, so that is the reason why we are taking n minus middle of A. What will happen here is this middle of A will be slightly shifted. In the first iteration, it will be fine, but in the later iterations, what will it do is it will just like get slightly shifted either when we will reassign the values of this high and low, no, what will happen is it will get slightly shifted. This middle point will get slowly shifted. Okay. So, hello.
Yeah, ma'am.
Yeah, so these middle elements will get slowly shifted. Either middle of A will come towards the right or this middle of B will go slightly towards the left and so on. Okay, so that is why we had the base cases when we had the condition that if left of A will be will be equal to 0. Okay, then what will happen? If left of A will be equal to 0, then what should we assign to left of A? not left of A, middle of A. If middle of A equals to 0, then what should I assign to left of it?
Negative infinity.
Negative of infinity, right? So it will be minus infinity. Otherwise, we can just assign the same thing, which is left of A is equal to A and middle of A minus 1. Similarly, for right of A also, if middle of A is equal to the last element, right, which is equal to n, okay, it is not the last element, the value after the last element, then what should be the value for right of A?
Infinity.
Infinity, positive infinity, right? So then we will be having, otherwise we have right of A will be equal to this A of middle of A. Okay. So this is the reason why we are having these base cases. What we are doing is we will be shifting this middle elements slightly in the later part so that we can actually compare these elements and we will determine where our middle elements will lie. Okay, so let me just write the code for this. This is fine, right? Okay. So now what we will do is we will compare where exactly our left of A and left of right of A are lying. Okay. So what first thing we will check is if my left of A is greater than C. There are three scenarios. The first scenario is this is exactly aligned to each other. Okay. The second scenario is this thing is shifted to the right. So this is the first scenario. Okay. The second scenario will be this is my left of A, right of A, and my left of A and right of left of B and right of B is over here. Okay. This is the second scenario where this first thing is shifted slightly. And the third thing will be this is my left of A, right of A, and for B it has shifted slightly to the right. Okay. So do you understand why this will happen?
Yes, ma'am.
Yeah. So what we will do is we will just like if you recall the binary search algorithm, we had that we used to shift the low and the high, right? Similar to here, similar to that, we will be shifting the low and high here. So because we will be shifting the low and the high, our middle points will shift in the later iterations. Okay, so that is why we will have our left and right slightly different to each other. Okay, so what we will have is we will look into the easy cases first. First of all, we will look into the second scenario, second case and the third case. So what will happen in the second case? How do I check if it is in the second case? I'll write the case one over here. The reason I'm not writing the case one right now is because I personally feel that the case one is slightly complicated. Okay, so we'll discuss the case one little bit later, and we'll discuss the case number two first. Okay, so how do we check if it lies in the case number two scenario? Can anybody suggest how to check whether it is in case number two or not?
If mid of A equals mid of B.
Case number two, this scenario.
Oh,
This particular
mid of
scenario.
A is greater than mid of B.
Yeah, so basically mid of B we have assigned to right of B. So in terms of left and right, can you suggest?
Left of A will be greater than uh, right of B.
Exactly. Left of A is greater than right of B. Okay, in this scenario, what will happen? Where will our middle element lie? So I have uh, this is my A, this is my B, sorry, it's of the same size, no? Okay, so this is the B. Now, where exactly do you think the middle elements will lie?
After right of B and before left of A.
After, uh, hang on, what? After?
Right of B and before left of A.
Why? Think along the lines of that this middle element represents a middle point. Okay, this represents somewhere in this range. Okay, we are just trying to reduce this range. We are not trying to find the, we are just trying to find the middle element in this merged array. So we are just fixing a range initially, and then we are just trying to reduce this range, similar to what you used to do in binary search. We had a low here, we had a high here, and then we kept on reducing this range, right? We used to shift the high or the low, and the range to search was kept going, was keeping on reducing, right? Similar to that, we are just trying to reduce this range. Okay, so we are saying that this is some kind of an element. I have reduced my range here such that my middle element will come before this, and here I have reduced my range such that my middle element will come after this. This will be the middle of the final thing, the middle point of the left of the middle and the right of the middle, something kind of that. But we don't know exactly the left of where the left of the middle and the right of the middle should go. Okay, so we are having these two lefts and two rights now. Okay, we had what, the left for A and left for B. So left for A or left for B, the minimum of them will lie somewhere around here, and the maximum of these two values will lie somewhere around here, and then we will, all the other values will lie here, right?
Yes.
Do you agree? See, for case one, in case one, what happens? Let's just shift for case one little bit. We'll come back to case two. Okay, we'll come back to case two. Let's look into case one, this case. So for this particular case, what will be the condition? How do we check?
Mid of
If,
A is equal to mid of B.
yeah, or left of A will be less than equal to right of B, and left of B will be less than equal to right of A. Is this correct? This is the more
Yeah.
general, what you said that mid will be the same. That is correct. That's not wrong. That is correct. But this is a more uh, generalized condition for the same thing. Okay. It is not like in case if you are like when you said that you can take right should be mid plus one, right? Here you were suggesting to take right
Yeah.
should as mid plus one. In that scenario, this will be helpful. Okay. We cannot claim
Okay.
that the element will be the same. So this is more of a generalized scenario. In this scenario, where do you think the middle element should lie? See, this is the array in the merged case, in the merged set. Okay, so merged list. So these are the two arrays. This is A, this is B, and now this is my middle element, middle elements. So this is my middle elements. Where do you think our middle element should lie? Notice that this is less, this will be somehow be, the middle elements will somehow be lying between these two elements, right?
Yeah.
These two, but the minimum of these two will form one of the boundaries, and maximum of these two will form one of these boundaries. And this set will be in the middle of these two. Do you agree to that?
Yeah.
Right? So all elements in this part and to the left of this part will come over to this range, right? And one of the the minimum of these two values will form the middle of this part, and the maximum of these two values will form the this element, right?
Yes, ma'am.
Yeah, so that is what we will be doing here. What we will do here is if this such a scenario arises, then we will just 1 minute. Give me a minute. Hello?
Yes, ma'am.
Yes, ma'am.
Yeah, so if such a scenario arises, then we will just mm, take the average of these two elements. Okay, so we will just take the average of. So what will be the value at this boundary of this element? Sorry, boundary of this range. The value at the boundary of this range will be minimum of
Minimum of left of A and left of B.
left of A and left of B. And the value at the right boundary of the Morse will be
Maximum of right of A and right of B.
right of A and right of B. And the average of these two will be the median actually. Okay. This is the first case scenario. The second case scenario is left of A is great. This scenario when the left of A is greater than right of B. In this scenario, where exactly will the middle lie? This range should come where? To this part, right? This half,
Yes.
right? So for this half, so how will we take into consideration this half? We will just take high is equal to middle of 1 minus, sorry. We will take fewer elements from this array 1 and hence we will do, okay, just give me a minute. Okay, there is one more algorithm which is really easier than this. Can we go to that algorithm? This explanation of this
Yeah.
particular algorithm is really,
Yes, ma'am.
yeah,
Yeah,
let's
ma'am.
go to that algorithm where we don't need this left and right, but we can just do with the middle elements. Okay, so let us just go. I'm really sorry, I should have explored this little bit earlier. Hello?
Yeah, ma'am.
Yes, ma'am.
Yeah, so this is a recursion algorithm. So let's just look into the recursion part and then we will look into the iteration. Okay, so we'll define this median function which has A, B, the uh, lower lower index of A, which is the left index of A, okay, left index of A, the right index or the right index of A, which is basically n minus 1. Similarly, for B, we have the lower index for B and the right index for B. Okay, hello?
Yeah, ma'am. Yeah.
Yeah, so now we take n is equal to, how do we calculate n? N is basically length of A, right?
Yes. Yes.
And our middle element is equal to, we had already assigned this middle should be equal to n by 2. So we will have the middle index is equal to n by 2. So we will have our middle of A is equal to the left index for A plus the middle. Okay.
Yeah.
Similarly, for B, we will have If it is the, okay, so what is happening here is, what's happening here is we have this A list, we have the B list, and we are taking the middle value for both of this. Okay, and now we are just assigning middle of A, median of A. Okay, let's call it median of A instead of middle of A. So median of A as the lower element plus the middle value. This is clear, this much.
Yeah.
Now for n, for B, what will happen is if my n is a positive number, sorry, if my n is an even number, then 2n will also be an even number, right? In the merged list, we will be having an even number. So we need the middle of two elements, right? So what we are going to do is if n is an even number, then we will assign the median for B is equal to left of B plus mid minus 1. Okay. Otherwise, we will assign median of B is equal to left of B plus the middle element. Okay. Now
Yeah,
let's
ma'am.
look into the conditions. The first condition is if my n is equal to 1. If my n is equal to 1, then what will happen? Base case.
Uh,
What do we do? If n is equal to 1, then what will be the median?
that itself will be the median.
How? What is n here?
N
Let's
is the
forget
length.
about this part. Let's forget about this part. We will look into the base cases first. Okay?
Yeah.
If n is equal to 1, then what will happen? N is the length of one array.
Yeah.
So the length of one of the arrays is 1. The length
Yes.
of the, because both the arrays are having same length, length of B is also equal to 1.
Yeah.
Let's see this case. A is equal to n is equal to 1, which means what is n? N is the length of both the arrays. Both the arrays are having the same length, right? So if n is equal to 1, there is one element for A and one element for B, right?
Yes.
What will be the median in this scenario?
Average of the.
Exactly. So we will return what? A of LA plus B of LB divided by 2. This is right. This is fine.
Yeah, ma'am.
Okay. The second scenario is what happens if n is equal to 2. What will happen if n is equal to 2?
Maximum of A and minimum of B, and then average of those.
Okay, suppose A has 1, 2, and B has 3. A has 3, 4, and B has 1, 2. What will happen then?
Uh,
Think about it. I just don't want to directly give you the answers. I just want you to think about why it is happening. So that's why I'm just asking you these questions. Otherwise, I can just type and you can just look into this. So I just want you to understand the concept behind it. So that's why I'm asking you. Suppose we have
yeah.
two elements. A is having 3 and 4, and B is having 1 and 2. Then what should be our median element? What should be the median value? How do we calculate it? Do you want me to say the solution?
Ma'am, maybe split A and B further.
Split A and B further, and what will happen then?
Then uh,
So
we'll
this is
reach
a
the base
simple
case.
scenario. This is a simple scenario. Why don't you just try merging them?
Yeah, but for two elements we can merge, but if n is bigger, we can't merge, right? Or else it will go
Yeah. We
overrun.
are just looking for the base case scenario. And this is one of the base case scenarios where n is equal to 2. Okay.
Yeah,
So
then
for
we definitely can merge.
yeah, merge and see and give me a formula which will work for any scenario when n is equal to 2. Try merging and see what is happening. Let's merge. Okay, what will happen here? If we merge this two, then we will get what? 1,
1, 2, 3.
2, 3, and 4, right? So this the maximum of this right element of B and left element of A are coming in the middle C, right?
Yes, yes.
What are the boundary elements? Let's try to eliminate the boundary elements, and whatever will be remaining, that will be the those two we will take the average, right? So what will be the boundary elements?
Boundary will be minimum of B and maximum of B.
Minimum of B of what? Minimum of
Yeah,
B,
B of left of B.
B of left and
Yes,
A of left. You take the minimum of both of them, that will come to the minimum of here, right?
yes, yes,
Similarly, for the right, what will happen? You take the right of B, the first index of B, the right element of B, which is the index 1 of B and the index 1 of A, and find the maximum. That will go to the right element, right?
yes.
So our left element will be minimum of A of 0 and B of 0, right? And the right element will be maximum of A of 1 and B of 1. Do you agree to this? Any doubts still for this? For these two base
No,
cases?
ma'am.
Okay. So whatever, apart from these two elements, whatever is remaining will come in the middle.
Yes,
So what is remaining? You have taken the minimum of A of 0 and B of 0. So the other one will be remaining, right? What is the other one?
yes.
The maximum one, right? So
Yeah,
what is remaining is maximum of A of 0. Sorry, maximum between A of LA and B
and
of
B of L. Yeah,
LB, right? And what else is
yes.
remaining?
Minimum of other half.
Other half. Yeah, so A of right of A
Yes,
and B of right of
right
B,
of B.
right? So the median will be basically the average of these two. Do you agree?
Yes.
Yes. So the average of these two elements, we can just return this. This is clear?
Yeah, ma'am. Clear.
Okay. Now comes the other case scenario for the general scenario. The general scenario, what we will look into is what happens if middle of A is equal to middle of B. Sorry, A of middle of A will be equal to A of middle of B. What happens in this scenario? So what we are saying is we will choose two elements. Okay. So what we will do is we will take a middle element defined as n by 2. Okay. And we will choose two elements, some middle of A and some middle of B around this middle. Okay. So what we have is we have this. Let me just draw a figure for that. This is my A. This is my B. N by 2 lies somewhere around here, right? Now n by 2 lies somewhere around here, which is my mid. Okay. So what I am going to do is I will choose a middle of A. Now we all know that our middle element must lie somewhere to the right of this and left of this, right? Somewhere around that.
Yeah.
So I will just choose a middle element somewhere around here and a middle element somewhere around this middle, okay, somewhere around this part, and I will choose a middle element somewhere around this part, okay, and now I am going to compare these two middle elements. If these middle elements are same, then what will happen? Okay, then we can safely say that our median will be equal to the average of these two. Okay, A of middle of A plus B of middle of B divided by 2. Okay, we can just return this. And why this happens? This again goes back to the definition of median. If you look into the definition of median, if you find two elements at equidistance from the middle element, you take the average of them, then it will be the median of that element. Okay, so that is again, if you go into mathematics and if you look into the definition of median and everything, then you will understand why this happens too. Okay, so this is the third case scenario. The next case scenario is when A of middle of A is greater than B of middle of B. What will happen now? I chose this particular element. Okay, let me use a different color here. I chose this particular element, let's say, okay, and for B, I am choosing this element, let's say, example, okay. So I am choosing these two elements. Now what I want is, I am claiming that this element is greater than this element, okay. I'm saying that this is somewhere around, these elements are somewhere around the middle of the range, like if we take the merged array, okay, our median element should lie somewhere in this particular range. And what we are claiming is these two points somewhere lie around in this range. Okay. But this point is greater than this point. Then what should we look for into? Which range should we consider next? How do we change the left of array, left of A, right of A, left of B, right of B, such that we can reduce this range further? I know that this middle of A element is greater than the value for middle of B element. Any guesses for that?
And we can
See,
reduce
if
left
we are
part by 1 and right part, I mean increase right part by 1.
yes, yes. So what we will do is we will return, let's say median will be equal to what? Our median will lie somewhere around. I'll go to the median function. Okay. So we will look into what? How will we reduce? Okay, let's just look into this. What was your solution for A? What we will do?
We'll reduce left part of A by 1.
Left part of A by 1. So right of A will be equal to middle of A, right?
Yeah.
So right of A will be equal to middle of A. And what will we do for B?
We'll reduce right part by 1.
Right part by
So
1. So
left
left
of
of
B
A
will
will
be
be,
mid.
exactly, left of B will be middle of B. And now we recurse on this sorter range. Okay. So what we will do is we will just call the median function again on A, B, left of A, right of A, left of B, and right of B. But here we have reduced right of A to middle of A. So I'll just put middle of A instead of right of A. And instead of left of B, we are taking middle of B as the left of B. So we'll take this is the middle of B. Right? We compute this and then we will return this value. Is this part
Yeah.
clear?
Yes,
Yeah.
ma'am.
Next, otherwise, what will happen otherwise? It's the opposite scenario. What is the opposite scenario? This value is greater than this value. Exact same thing,
Then
but opposite. Yeah,
we'll make the right of A as mid of A and left of B as mid of B.
isn't that what we just did now?
In that case, oh yeah, then for uh, left
This
of
will have
A, we'll make mid of A.
exactly. Yeah, left of A will be mid of A. The right will be higher. The left of B will be the same, which will be left of B, and
Yeah,
right of B will be mid of
right will be mid. Yes.
okay. So what happens is because our this suppose if this value is greater than this value, then it is most likely that the smaller values will lie somewhere around here. Okay. And again for this one, the smaller values, the greater values will lie around here. So to find the median, what we are going to do is we will look into this half and into this half. So we want to find two elements which will be equidistant from the end. So that will give us either this half or this half. Okay, so that way we will be able to find two elements which are equidistant from the end when we can take the average of that. This is what we are doing in this particular method. Okay, so I hope this method is clear except the part where we compute what is mid of A and mid of B. Okay, so how do we compute mid of A and mid of B? So what we can do is for mid of A, we can just say that L of A is equal to, sorry, mid of A equals to left of A plus the middle element. And for mid of B, what we will do is we will just find if the n is even, then we take mid of B is equal to left of B plus the middle element minus 1, else we can just take middle of B is equal to left of B plus the middle element. Is this clear or any doubts?
Not clear.
This is clear, right?
Yeah.
Okay. So now what happens is once we have, because we have already found the middle element, we know how to compute the n by 2th element, right? So median is basically the n by 2th element. So we know how to compute the n by 2th element in the merged array. So what the next question asks is, we want to find the kth element. So if we say that, if we go to the second question, in the merged array, we want to find the kth element from the left. So you start from the left and you go to the kth element. Okay. Hello.
Yes, ma'am.
Yeah. So you merge the array and you start from the like for example, if my k is equal to 3 and if we merge these two lists, we will have 1, 2, 3, 4, 5, 5, 7, 8, right? So what will be the third element? The third element will be at the location of 3 minus 1, that is 2. So at the location to index 2, we will have 3 and the output should be 3. But if I am asking for the sixth element, then you have to look at the fifth index and the fifth index will be 0, 1, 2, 3, 4, 5, 5. Okay, so that is the question. How do we compute the kth element? So do you want to think about it? It will be very similar to this particular solution.
We'll again have to use the binary search method.
Yes. Do you want to think or we will just go to the solution?
Ma'am, we can just go to the solution.
Okay, so if we are going, okay, so let's do, so what we will do is, Now I guess we have this different lengths. Our arrays may be of different lengths. I believe in the previous question also the arrays may be having different length or something, but the same solution will work. Okay. So here we will be looking into the kth element. Okay. We are having two arrays A, B, and their lengths, which is n and m. And let's just forget about n and m. And we have the scale. Okay. So what we will do is we have n is equal to length of A, m is equal to length of B. Okay. So now we will look into the base cases first. So for the base cases, the first base case is if n is equal to 1 or m is equal to 1, what will happen?
Then we check if k is in the range. I mean, k is equal to 1 or less than 1. If not, then we return none or minus 1, or else we return the first element or zeroth
Yeah.
element.
Yeah. So we have two elements, right? Oh, sorry. One of these elements is okay. What was your solution? If k is equal to 1,
If k is greater than 2,
okay. If k is greater than 2,
greater than equal to 2,
okay.
yeah, then we return minus 1 or none as per the requirement of the question, or else
Not necessarily. No, 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 no. Wait, this or this is not and.
yeah, if both uh, a and b are of length 1, that means only two element is present. If we merge them, we will get
This
zeroth
is
and
and
first index.
condition. You are saying for the and condition. Both A and B are having the same length 1. So if
Yeah,
k is greater than uh, k is actually here they are asking if it is 2, then we will return the index 1.
yes.
So it should be greater than 2, right?
But we have only two elements overall. If we merge those a and b, since they both are
We
1,
have two elements, right? If my
yeah.
k is equal to 2, then I can return the second element, right?
If k is equal to 2, then we can't return. We have to return the element at that index, right? So we have only zeroth
Let's
and
check the
first.
question what it is asking. Okay, the question is asking what? Kth element, not the k element. Element of
Okay.
index k, kth element. 1, 2, 3, 4, 7, 8, 9, 10, 12, 13. At the fourth index, it will be like at the fourth element will be 4, but index 4 will have the value 7. We are returning 4. So we want the fourth element. Index will be
Yeah,
k minus 1. Okay. So if k is
yes.
greater than 2, then we will have uh
We can't return anything.
we can't return anything. So we'll return minus 1. Otherwise, what will happen if k is equal to 1?
We return the minimum of a or b.
A of uh,
Yeah, a of 0 and
0
b of 0.
and B of 0.
Or else we return maximum of a of 0.
Yes. This is fine. Okay. Now the second condition is if both of them are either one of them is equal to 0. If n is equal to 1 or n is equal to 1. One of them is having the length 1, the other one can have any length.
Yeah, then any k greater than 1 will return minus 1.
Why? We have one of them is equal to length 1.
Yeah. So
Let's say
anything
n is
greater,
equal to 1. Let's say n is equal to 1. Okay. My n is equal to 1. M is of any
And
weight.
m is 0, right?
No. M is not 0. M is some value. It is something
Okay.
similar to this. This is
Okay,
A.
means eighth, yeah. I mean, A list is length 1 or m can be anything.
Yes.
Okay.
Then what do we do? If k is
Then
equal to 1, then what will happen?
we just merge A into B and return the required element.
Yeah, that is fine, but this is the base case. So let's just look into the scenarios. If k is equal to 1, then what will happen? This is actually a pretty easy scenario. Think about it. If k is equal to 1, then what will go into the first element?
If A of 0 is less than B of 0, then we return A of 0.
Yeah. Otherwise, we'll return b of
Otherwise,
0,
B
right?
of 0, yeah.
So basically, we will be returning minimum of a of
A of
0
0
and
and
b
B
of
of 0.
0, right?
Yes.
Secondly, if k is equal to m plus n, or in other words, it is equal to k is equal to m plus 1. Okay, n is equal to 1, right? So if this scenario arises, then what will happen?
Maximum of A of 0 and B of minus 1.
Exactly, maximum of a of 0 and b of minus 1. Okay. Otherwise, what will we do? If what can we do is we can just go to k minus c. We can go to see what will happen is when we merge this element, my this one element will be increased somewhere, right? So all we'll
Yes.
need to look into is the k minus 1th element or k minus 2th element or something like that, right?
Yeah.
So what we will do is we'll look into uh, b of k minus 2. Okay. If b of k minus 2 is greater than a of 0, then what will happen?
Ma'am, why K minus 2?
A k minus 1th index we have to return, right? We have to return the k
Yeah.
minus 1th index. So we are looking
Yes,
to the
yes.
previous value, k minus 2.
Okay.
Okay.
Ma'am,
So if
but we should check with K minus 1th element.
you want to check with k minus 1th element,
Yeah, if we have
okay,
to
let's check.
return that, if we
Okay,
have to
let's check.
return that, then we check that element and A of 0, whichever is bigger, we return.
Why do you want to return that? See, if my k minus 1th element is greater than a of 0, then my a of 0 lies somewhere over here and my k minus 1th index will shift. Okay,
No,
let's go to the other scenario. Let's go to the other scenario.
yeah, yeah.
My b of k minus 1 is less than a of 0. Then what will happen? In the Mars list, what will happen? B of k minus 1 is less than a of 0. So where will my a of 0 lie?
A of 0 will lie at K minus 1th index.
No, after k minus 1th index, right?
Oh,
This value
yeah,
is
K
less.
at Kth index. Yes.
Yeah, at kth index or somewhere after this. Somewhere after this it will lie. It will not lie
Yes.
before this. Right? So we can just return this k minus 1th index.
Yeah.
Right? So I will return b of k minus 1th index. Otherwise, what will happen? My k minus 1, this value is greater than this value. This value is
Yes.
greater than this value. So this value will lie where?
Before K
Somewhere
minus 1.
here. before k
Yeah.
minus 1, right? So where will it lie? Either it can come to this k minus 2th index or it can go somewhere before that, right?
Yeah. Yeah.
So which one should we return now? If it comes to the k minus 2th index, then we will have to return a of
Minimum
0.
of
Yeah. So
yes.
if it comes to the k minus 2th index, we will have to return a of 0. If it is not going to k minus 2th index and goes to somewhere else, then we will have to return the b of k minus 2th index.
Yeah.
Right? So basically, we have to return the minimum of these two values. Is this part
Yes.
clear?
Yeah, ma'am. Yeah.
This is for n is equal to 1. The same thing will happen. We can repeat for m is equal to 1. I will not write that, but you can look into what will happen into if m is equal to 1. The same thing, but the
Yeah.
opposite. Okay. So
Yes.
if m is equal to 1, what happens? You can write over here. You have to fix this where a will become b and b will become a in this scenario. Okay.
Yes. Yes.
Okay. The next part is in the general case. So what we have is we have a middle value for A, which is basically equal to uh, n by 2, and a middle value for B, which is equal to m by 2, right? Yeah. Now what will we do? So let's go to this, draw this figure. There is an A, there is a B. Both of them can have different length. So now middle of A, I have a middle of A over here. Middle of B is over here. Okay. So now how will I determine where my K will lie? The first condition is what happens if K is greater than middle
Mid
of
of it.
A plus middle of B plus 1. This plus 1 is basically because of the index. This is basically K minus 1 is greater than this. Okay. So if my
Okay.
kth value is greater than middle of A plus middle of B. So how does this look like in the merge list? Okay, I'll draw in a different color the merge list. This is the merge list. My middle of A will lie uh, somewhere here.
Yeah.
Middle of B lies somewhere here. My K minus 1 at index is somewhere around after this. So
Yes.
what should I look into? Which area should I look into for both of these areas and this areas? Which area should I look into?
Right of A and right of B.
Right of A and right of B, I agree, but that is a little bit more complicated. We should also look into the values. If A of middle of A is less than B of middle of B. I'll just tell you what the conditions are and you can tell me which part you should look into, okay? So I'll look into which part over here. Otherwise, if for the other condition, where we should look into, is similar to this scenario, okay?
Yes, ma'am.
Let's just discuss this part, then we will come back, okay? So this is
Okay.
for the case. Yeah. So what happens if my middle of A, see here I have, this is the middle of A, this is coming here, and the middle of B, middle of A value is less than middle of B value. So this one is middle of A, this one is middle of B. Okay. So what
Yes.
lies after this?
Then we should just
So we can just, to be on the safe side, we can just look into this range and this entire array, right?
You mean entire array of B and half of I mean right part of A.
Right part of A and right part of B. That makes the most sense, right? If my K is
Yeah,
greater
yeah.
than middle
Yes,
of
yes, yes.
1 and middle of 2. I don't know why they
Yeah.
have given this way, but I don't know why they have given this way, but what makes most sense is if my K minus 1 is greater than middle of A and middle of B, then I can just look into K of A of middle of A plus 1 till the end. B will go to middle of B plus 1 colon, right? This is correct, right?
Yeah, ma'am. Yes.
And what should be the value of n now?
N will be N by 2.
Yeah, we can just write length of A to middle of A plus, or we can just write n will be equal to uh, n minus middle of A minus 1.
Yeah, just half of the previous.
Yeah. Let me just delete this part so it will be visible. This will be m will be equal to n minus middle of B. No, it's not the half. It's basically this part, the length of this part. This is middle of. We are taking this element, middle of A plus one element. So the number of elements in this area will be n minus middle of A minus one, right?
Yeah. Yes.
That is what I'm doing here. N minus middle of A minus one.
Ma'am,
This
why
is
that
clear.
minus one is needed?
Okay. How many elements will be there? In this part, how many elements will be there? We are
N
not
by 2
including
elements.
the middle element.
Oh, we are
Uh,
not in.
we're
Yeah,
not
yeah, we are
including the
not.
middle.
Yeah,
So
then
n
N by
minus
2
middle.
minus 1. Yeah.
Yeah, or in other words, it will be because we are taking in binary search, you must have remembered, right? My
Yes,
higher
ma'am.
index and lower index are changing. So your index is
Yeah.
changing. So instead of taking n by 2, I'm just subtracting n
Yeah,
minus
yeah.
middle of a minus 1. Okay. And here we
Yes,
will be
ma'am.
having m minus middle of b minus 1. Now the interesting thing is what will be k? See, here I don't have to look for in this particular subarray, I don't have to look for the kth element.
Yeah.
Which element should I be looking for? I should look for the
Mid of
k.
A plus M plus N minus mid of A plus mid of B.
Sorry?
M plus N minus
Yeah.
the other part we just removed.
Yeah, minus this part that we removed. So it
Yes.
will be middle of A plus middle of B. Yes. So we can have this is equal to n plus n minus middle of A minus middle of B, right?
Yeah.
Or we can say this as I'll just write this in a this will be minus, so I'll just write it in a little bit of a this is fine.
Yes, ma'am.
Yeah. Next condition is what if my k minus 1th index is less than both middle of A plus middle of B. The other scenario, it lies somewhere around here. Sorry, middle of lies less than, sorry, middle of A plus, wait, this condition is slightly wrong, right? We want to look into this right half. So what will be this part? This will be maximum of 2 or what? This will not be, this will be basically middle of A plus middle of B. Yeah, this part is correct. This part is fine, right?
Yeah,
Now I want to look into this part. So what is this part? What will be
mid
this
of B
index?
minus mid of A.
Uh, Absolute value of that, right?
Yes, absolutely.
Mid of B minus mid of A. Why absolute value? This can be mid of, if this is mid of P and this is mid of A, then we will be taking mid of P minus mid of A. No,
Yes,
mid of P. No. This will be minimum of both, right? This part. Mid of B minus mid of A will give me this part.
okay.
What we want is it should be less than mid of A and mid of B. Right? This kth value is
Yeah,
less than both middle of A and middle of B. Then it will lie in this part. Right?
yes.
So what do we do now? Where do we search?
Ma'am, but mid of A as it was in the A list and mid of B as it was in the B list might not be same in the merged list. I mean their positions might
Yeah.
not.
The positions might not be same, but it will be the values will lie somewhere, right? That's what I'm saying. I have one particular this middle of A and middle of B. This particular value has come here. This is not the middle exactly. And here also this value has come here. That is not the middle, but it is lying somewhere around. Okay.
Okay.
So what I
Yeah.
am going to say is I am going to see that the right of everything, both of these values, I'll see to the right. First condition is I'll see to the right of both of these values. The second condition is I'll see to the left of both of these values.
Ma'am, in that case, for the first condition, when we were considering mid of A plus mid of B, instead of that, shouldn't we consider the max of mid of A and mid of B?
Yes. Actually, why mid of A plus mid of B also works, I will tell you that. Okay. You can actually look into max of mid of A and mid of B. Okay. So now why both mid of A plus mid of B worked? Because notice that we have mid of A elements here and mid of B elements here, right? All of these elements comes to the back of this part. Whatever will be here,
Yeah.
let's say this is mid of B, okay? So everything before mid of A and everything before mid of B must come to the left of mid of B here.
Yes.
That is why mid of A and mid of B was also working. But let's go with max of mid of A and mid of B. Okay. So if we're taking max of mid of A and mid of B, it means that I am to the right of the right value. Okay. Whatever will be
Yeah.
there here, wherever mid of B is or mid of A is, whatever is at the right value to its right. I'll look into the right part, this part.
Yes, ma'am.
Okay. Now I'm going to look into the left part. So in the left part, which part of these four segments, which part of these four segments will lie in the left part? I have to choose that.
Yeah.
So what will I do?
If A is minimum, then we'll search in left of A. I mean, mid of A is minimum, then we'll search in left of A.
Not necessarily. There can be some values which will be lying here and then this will come over here somewhere. No, that is also possible.
Oh, yeah. Then we have to search in left of A and B both.
Yes, we have to search for both left of A and left of B. So we'll go from zeroth index to from the leftmost index of A to this index. Okay. So this will be mid of
Yeah.
A minus 1, or let's just go with mid of A. Okay. And
Yeah.
then we have B column mid of B, and then we have, and what will be the length here now. Length of this row. Sorry,
n
length
minus
of
mid
this
of a.
array. It will be mid of A. Why n minus mid of A?
Oh yeah, this will be just mid of a. Yes,
This will be mid of A. For B,
mid of b.
mid of B. What will be the K value now in this particular thing? K will actually still be K,
Yeah,
right? We want the Kth element. Okay. So now we have, if my K lies over here, I'm done. If my K lies over here, I'm done. Now the complicated case is if my K lies between these two values. Okay.
yes.
So it basically K is greater than the minimum of these two values and K is less than the minimum of these two values. So in that scenario, where should I search?
In
Now I have to look for if what is the value of A of middle and B of, middle of A and middle of B. What happens if A of middle is greater than B of middle? What happens if in the other scenario? What happens when A of middle of A is greater than B of middle of B?
then
Then
we search after a of mid of a, but before b of mid of b.
no. You're getting confused. My A of middle of A is greater than B of middle of B. Okay, so that means what? My middle of B in value should lie somewhere here,
Yeah.
and my middle of A will come somewhere over here.
Okay. Yeah. We have to then search for after mid of b and before mid of a.
Exactly. So we will return kth of what should we search?
We should
A of
search.
left of A, right? Left part of A
Yeah.
and right part of B. So left
Yeah.
part of A is basically colon to mid of A, and right part of B is middle of B plus
Plus 1, 2, 2 and
colon. Now what will be the n length? Length of the subarray of A that we are considering. This
yeah, mid
length,
of a.
right? Mid of A. And for B, right? This
M
length, what
minus
will be
mid of b minus
n
1.
minus mid of B minus 1. Now what will be the value of K?
K again will be as it is.
Why? We are already excluding this middle of B elements, right?
Yeah.
This set of elements we are excluding. So from here, which element? So from here to here is K. So what will be the value from here to here?
M minus mid of b will consider for
No.
k.
K minus mid of B. See, let me just draw here a little bit. This is my K. Okay.
Yeah.
This is my K. So now what I want is I am just excluding this array. This part of the array I will be excluding. So I will be searching only for this length. So now I have to determine what is this, right?
Yeah.
What I have to determine is what exactly this element is. What is this element now?
Minimum of mid of a and mid of b.
Why? I have already decided that my mid of A is coming
Yeah.
over here.
That is mid of b then.
So this is mid of B. If this is
Yes.
mid of B, then what should be this length, this region, this part?
K minus mid of b.
Exactly. It will be K minus mid of B. Okay. So I'll just
Yeah,
delete
ma'am.
this little bit. It will be K minus mid of B. Okay. The other case will be exactly opposite.
The
Here
opposite
what
of
is
it.
happening? Yeah, here what is happening? A of middle of A is greater than B of middle of B. So we know that this value is middle of, A of middle of A is greater than B of middle of B. So this
Yes.
value will be, no, the opposite case is A of middle of A is less than B of middle of B.
Yeah.
So this value will be middle of A.
Yeah, the
This will
first.
be middle of A. and this will be
Yeah.
middle of B. So which reason should we look into?
Then we should look right half of A and left half of B.
Yeah, right half of A will be equal to middle of A plus 1 colon, and left half of B will be equal to colon to middle of B. What is the length of N? This length of the right half of A, which we will be looking. That will be
Yeah, N minus middle of
N
A.
minus middle of A minus 1, and left half of B, length of the
Just
left
middle
half
of
of
B.
B, middle of B. What will be the K length now?
K minus mid of A.
Exactly, K minus mid of A. Okay, so this is the entire solution. Is that clear or any doubts?
Yeah. No, ma'am, it's clear.
Okay, then let's go to the third question. The third question is comparatively simpler. Mhm. Hang on. This is a different question than what I was told earlier. Okay, so let's look into this question. Given a circularly sorted integer list, find the total number of times the list is rotated. Assume that there are no duplicates in the list and the rotation is in the anti-clockwise. Okay, so what we are doing is we are rotating this list. We have a sorted list. Okay, now let's rotate it once anti-clockwise direction. So what will happen if I rotate it in an anti-clockwise direction? This 5 will come to the beginning, right? I'm just
Yes.
shifting everything. So my 5 will come to the beginning, and then I will have 1, 2, 3, 4. Similarly, after second rotation, what will happen? My 4 will come to like I will be shifting everything by one index. So my 4 will come to behind 5, and it will become 4, 5, 1, 2, 3, right? So the question is we have to find, we will be given this L and N elements which is circularly rotated K times. We don't know the value of K. We don't know how many times our elements has been rotated. Okay, we don't know how many times this rotation has been performed. So what we want to find is we want to find the number of times this rotation has been performed. Okay.
Yeah.
Okay, so how do you do that? Any ideas for that?
Ma'am, what we can do is we just start with a binary search. We check the middle element.
Yeah.
Since the list is sorted and then rotated, so if it is not rotated, then the middle element will be always greater than its previous, I mean, left element, and lesser than its right element. But if the middle element is uh, l- if the middle element is lesser than its left element, then that index gives us the number of rotations.
Exactly. Yes, you are correct. Okay. So what we will do is we will keep on performing the binary search. We will take the middle element and we will see if it is greater than the left element. If it is greater than the left element, then well and good. So let's just do that. Okay. What happens? We
Yeah.
have the find rotations or whatever of this list L. Okay. So what we will do is we'll find the middle. N is equal to length of L. Low is equal to 0. High is equal to N minus 1. The first index and the last index. The middle will be, I'll write the while condition here. So middle index will be equals to low plus
High by 2.
high by 2. And then what will we do? We'll check if the middle index, sorry, if A, let's take A or L, what was that given?
L.
L, okay, let's take L. If, mm, if L of middle is greater
Is
than
less
L of is less than
less
L
than
of
L of mid minus 1.
mid minus 1, then what will happen? My
That
L of,
the in then mid is
yeah,
the number of rotations.
yes, then we return mid. Otherwise, what happens? If L of mid, otherwise my L of mid is greater than L of mid minus 1, right?
Yes.
So my middle here lies, see, the first scenario what you said, if my 1, if my middle value is equal to 1, okay? If this is my middle
Yeah.
element, then this is the number of rotations, right?
Yes.
But now what happens if here I have the middle element? There are two more scenarios. My middle element lies
Yeah.
over here and my middle element lies over here.
Yes.
Okay, so how do I determine where to go?
If we see that the element after the middle element is lesser, then we go to the right part, or else we go to the left part.
Sorry, can you please repeat?
If the lm I mean the if m plus 1th element is lesser than the mid element, then we
Okay,
go to the right part.
if n plus n minus 1th element, right? The last
No,
element,
mid plus 1th element.
mid plus 1th element, okay,
Yeah, is
is less
lesser
than.
than the mid, then we go to the right part.
Obviously, it is if see if this is less than this, I'm
If
not getting what you're saying.
suppose here we have 3, if we had after 3 we had some element that was lesser than 3, then we would check in the right part.
If there is 2 here, now suppose there was
Yeah,
2 here,
yes ma'am. Then
that
we
scenario
go,
cannot arise, right? Our list was already sorted.
no, after rotation that can happen.
After rotation, this can happen. So you are saying
Suppose,
that 10 is equal to the middle element. The middle element is 10 here.
yeah,
Suppose. Then what
yes,
happens? My right element is less than 10.
yeah, then we check after the middle element. I mean, we increase the lower to mid plus 1.
Actually, if such a scenario happens, if this is less than this, then we can just return the mid plus 1, right?
Yeah, then we can just return it.
Right? So
Yes
if
ma'am, yes.
L of middle is greater than L of middle plus 1, then we can just return mid plus 1, right?
Yes, yes.
The next scenario is what? Our yeah. So the next scenario is my left of middle is less than. So the next scenario is L of mid looks something like this. L of mid minus 1 is less than L of mid, which is less than L of mid plus 1. Okay,
Yeah,
properly sorted. Like 9 is the middle or 3 is the middle.
yeah.
Either 9 is the middle or 3 is the middle. Then what will you do? Let's say 3 is the middle. Let's consider this scenario when 3 is the middle. Okay. So what will we do? This is
We check in the left half.
how do we know that? Whether we should go to the left half or whether we should go to the right half. This is the trick where you take the high and the low values. Okay. You check for the higher values or the mid value with respect to the low value or the mid value with respect to the high value.
Yes, yes.
Right? If I check the mid value with the low value, let's do that. If L of mid is greater than L of low,
L of low.
then what happens? This is what is expected.
Yeah. Then the list is not rotated.
Let's go to the other scenario. L of mid is greater than L of high, right? This is this scenario. My middle
Yes.
is 9. Okay, L of mid is 9. So this is greater than my high is 7. So 9 is greater than 7. Okay, so where should I look?
Yeah.
I should look into the right part, right?
Yes.
Then I should look into the right part. So return find rotations of L, sorry, L of
And we are
I.
using while loop, so we should uh, make low equals to low mid plus one.
Yes, you're right. Low equals to low plus 1. Okay. The other
Yes.
scenario is, okay, so my L of mid is greater than L of high. The other scenario is, see, any one of these scenarios will happen. Either L of mid will be greater than L of mid plus 1, sorry, L of mid will be greater than L of high, or L of mid will be less than L of, uh, or L of mid will be less than L of mid minus 1, L of
Yeah.
low. But the other, any other case scenario will not happen, right? So we'll look into L
Yes.
of mid is less than L of low. This is what scenario? This case. My L of mid is 3, my low is 8, and my 3 is less than 8. Right? L of mid is
Yes.
less than L of low. Then where should we look? We
In the
should
left
look
part,
into
you
the
said.
left part. So my high will be equals to mid minus 1. Right?
Yes,
High
ma'am.
will be equals to mid minus 1. This will be equal to mid plus 1. This is clear, right?
Yeah, ma'am.
Yeah, that's it. Nothing else. Have you missed any other scenario?
No, ma'am. All the scenarios are covered.
All the other scenarios are done, so this is also done, and hence if such a scenario does not exist, then you can just return minus one or something like that. It will find somewhere something.
Yeah.
This is clear,
This
right?
was similar as finding peak, which we did in week 2.
You did finding peak.
Yeah, ma'am.
Yeah, okay, then this is the exact same problem. Similar, like very similar problem, kind of, right?
Yes.
Yes. Okay, then any other doubts, then we can discuss or we can stop.
Ma'am, I had
Uh,
it out in graded assignment of week 7. Since its day is past, can we discuss that?
Sure, but I have to stop. I believe I will have to stop the recording.
Sorry, in GRP of week 7.
Okay, which question?
Just a sec.
Okay, if anybody has any doubts, then please let me know. Otherwise, we can just stop the streaming and the recording regarding these three problems that we discussed today. Okay, in that case, I'll stop presenting and who had doubts? Devanshu, you had a doubt, right?
Yeah, ma'am. Yeah.
Yeah, we can discuss after stopping the presentation, okay?
Okay.
Yeah, I'll stop the streaming.
Yeah.
Okay, go ahead. Which question?